At exactly 6 a.m. local time, it started. From a hidden launch site in eastern Ukraine, 31 long-range strike drones quietly lifted into the sky. No noise, no warning, fully automated. Nobody saw them go. More than 1,400 kilometers away, inside a sleek 28-story office tower in central Grozny, the morning looked completely normal. Staff from the Chechnya Security Council were logging in, sorting files, planning their day. They had no idea that in just 8 hours, Ukrainian weapons would come crashing through their windows. 3 minutes after the first launch, Phase 2 began. 43 smaller drones rose from scattered positions across Kharkiv Oblast. These weren't built for deep strikes. Their mission was different. Distraction. They headed straight toward heavily monitored airspace in northern Luhansk, right into the teeth of Russian air defenses. Radar operators picked them up almost instantly. At first, the signals were faint, flickering dots that looked like birds or background noise. But then the screen started filling up. 8 contacts, then 15, then 23. This wasn't interference. This was an incoming swarm. Air defense crews scrambled. Commanders demanded firing authorization, while operators raced to separate real targets from radar clutter. The window to decide was shrinking fast. At 6:07 a.m., a Buk M3 missile battery fired the first shots. 4 surface-to-air missiles exploded off the rails, tearing into the sky at 4 times the speed of sound, aimed at drones worth a fraction of the cost. Seconds later, 4 drones vanished in midair. Debris rained down over frozen farmland. The rest of the swarm didn't hesitate. They pushed forward, spreading out, forcing defenders to track multiple threats at once. Then a Panzer S-1 system joined the fight. Its twin cannons roared to life, tracer rounds streaking upward as drones closed in. When some targets climbed beyond gun range, the system switched to missiles, turning the sky into a layered defense zone. And this was only the beginning. At exactly 6:07 a.m., the air defense fight was in full swing. 2 more drones were shot down, then 3 more. Crews worked through targets with machine-like focus. But there was a problem. The math didn't favor them. Expensive missiles were being fired at cheap drones. Buk interceptors were disappearing fast. Even the lower-cost Pantsir missiles were far more expensive than what they were trying to stop. The defense systems were winning tactically, but losing economically. By 6:12 a.m., the Buk battery hit a wall. 16 missiles fired, 12 drones destroyed. The launcher was empty. The Panzer unit was still fighting, but it was down to its last 3 missiles, constantly shifting position to plug gaps in coverage. Farther east, Tor batteries joined the engagement, launching vertically in quick succession. But as the distances grew, the chances of a clean intercept dropped. By 6:14 a.m., 19 drones were still in the air. Some Russian batteries were reloading. Others were close to running dry. From their perspective, the worst seemed over. Crews shifted focus to resupply and damage checks. That's when the real operation slipped through. 3 long-range strike drones, flying low at just 400 feet, had been moving quietly the entire time. The timing wasn't luck. Ukrainian planners had studied reload cycles, engagement habits, and radar coverage down to the minute. The drone swarm wasn't just a distraction. It was engineered to overload attention. Operators were watching ammo counters refill, not scanning the quiet southern sector. No alarms, no missile launches, nothing to suggest the most important targets were already past the line. At 6:15 a.m., the 3 strike drones climbed to 2,500 feet and turned southeast. Behind them, the diversion swarm still held defenders' focus. Crossing the front line was only Phase 1. What followed was an 8-hour autonomous flight across one of the largest countries on Earth. By 6:30 a.m., the drones settled into cruise mode over the empty eastern steppe. Their small gasoline engines pushed them forward at about 180 kilometers per hour, a steady pace they would maintain for hours. Unlike the decoy swarm, these aircraft were built for one purpose: deep strike, and they were just getting started. These strike drones aren't built to look impressive. They're built to survive. The engine sits behind the wing in what's called a pusher setup. That's not for style. It pushes exhaust heat backward, making the drone harder for infrared sensors on the ground to detect. Even the engine's metal mass, normally a strong radar reflector, is positioned where ground radar sees the smallest profile. Up front is the payload, a 75-kilogram high-explosive warhead wrapped in fragmenting steel. No fancy seeker, no last-second targeting camera. Once launched, the mission is locked in. The center of the drone carries everything that keeps it flying: fuel, navigation gear, and the onboard computer. About 80 liters of regular gasoline sit in a flexible tank. The wings are shaped for efficiency, letting the drone cruise at low throttle while the engine runs cool and lean. That efficiency adds up. These aircraft can stay airborne for 10 to 12 hours and travel roughly 1,500 to 2,000 kilometers depending on conditions. More than enough for deep missions. But the real brain of the operation is the mission computer. About the size of a smartphone, it handles autopilot, navigation, and flight control inside a hardened shell. At its core is an inertial measurement unit. Accelerometers tracking movement, gyroscopes tracking rotation. Instead of relying fully on GPS, the drone constantly calculates its position from where it started, measuring every motion along the way. It's called dead reckoning. And it isn't perfect. Tiny errors build over time. After 8 hours, the estimated position could drift by hundreds, even thousands of meters. Back in Ukraine, operators weren't watching live video. That would broadcast a signal easy to detect. Instead, every 15 minutes, each drone sent a quick burst of compressed data, less than half a second long, just enough to report position, altitude, heading, engine health, and remaining fuel. Then, silence again. 3 icons crept across a digital map: quiet, autonomous, still on course, and getting closer. The operators weren't flying these drones in real time. They couldn't steer them, couldn't jump in and fix anything. From launch to impact, the mission was fully autonomous. At 6:45 a.m., one drone reported a small deviation, about 340 meters off course. No panic. The onboard system corrected itself, nudging the heading by just 2 degrees. Operators logged it and moved on. Ahead was nothing but hundreds of kilometers of empty terrain. By 9:30 a.m., the second drone crossed into Kalmykia, cruising at roughly 2,800 feet. Below it, endless steppe, sparse roads, a few ponds, almost no landmarks. That wasn't accidental. Ukrainian planners study Russian air defenses constantly. Satellite imagery, signals intelligence, human reporting. Russia has dozens of air defense regiments, but not enough to seal every approach. Heavy protection sits around Moscow and Crimea. Frontline zones get tactical coverage. Kalmykia? Quiet. No major bases. No strategic industry. A drone flying at 3,000 feet might ping an early warning radar once in a while, and often gets dismissed as clutter. But missiles aren't the only threat. Russia also hunts with fighters. Earlier that morning, 2 Su-35 jets scrambled from a nearby airbase after the diversion swarm appeared. Doctrine assumed a larger operation might be underway, so pilots began sweeping likely approach corridors. Their radar could spot large aircraft from hundreds of kilometers away. These drones were another story. Their small composite frames reflected very little. Sometimes they looked like birds, sometimes like noise. Detection came down to angle, altitude, and luck. The fighters carved north-south patrol patterns at 15,000 feet, scanning wide areas surface systems couldn't reach. By procedure, not specific intelligence, their patrol zone overlapped the drone corridor. Then came the toughest stretch. At 9:47 a.m., one drone entered a navigation dead zone. The grasslands below were nearly featureless. Dirt roads had shifted since the last satellite pass. For 11 minutes, the system struggled to match reference points. Error estimates began creeping upward. 35 meters, 70, 120. Confidence dropped, but the drone kept flying. Autonomous, silent, still on mission. At 9:52 a.m., the drone caught a break. A highway interchange came into view. The onboard processor matched it instantly. Confidence shot up. Position error shrank to just a few meters. Course corrected. Mission continues. Minutes later, one of the patrolling fighters picked up something strange. A faint radar blip that lasted barely a second. Then another. Slow-moving, not quite bird-like. The jets turned to investigate. By 10:03 a.m., they dropped to 8,000 feet and scanned the ground with targeting sensors. Nothing. Grass, roads, shadows. 3 minutes earlier, the drones had descended to just 400 feet, not to evade fighters, but to improve navigation matching. That drop also tucked them below the radar horizon at exactly the right moment. The fighters logged the contacts as false returns and moved on. But the near miss raised concerns. The current route risked navigation drift near the target. Operators couldn't take manual control, but they could adjust the plan. During a scheduled check-in, a short satellite burst uploaded a new route, slightly longer but safer, threading the drones through known electronic interference zones. At 10:45 a.m., all three drones confirmed the update. 2 hours later, the environment changed. GPS signals began to weaken. Russian electronic warfare nodes lit up, creating overlapping jamming zones across a wide stretch of terrain. At first, military-grade receivers held steady. Then the signal vanished. Navigation switched to backup systems, inertial tracking, and visual matching. At 1:05 p.m., one drone made a mistake. A river bend looked like a reference point, but it wasn't. The system accepted the false match. Error stacked quickly. Within moments, recovery was impossible. The drone slammed into open terrain at speed. Its icon disappeared without a final word. Two drones remained. At 1:47 p.m., the first struck the eastern tower of the Grozny City Business Center, high on the 28th floor. 8 seconds later, the second drone hit several floors below, inside the Security Council offices. Both warheads detonated instantly. Damage clustered exactly where the targeted administration operated. Despite heavy GPS jamming, the mission didn't fail. The drones weren't dependent on satellites alone. Interference caused random drift, not total loss of control. Two aircraft reached their destination, mission complete.